Dear students, welcome to my YouTube channel आओ केमिस्ट्री सीखें। लेट्स एंजॉय केमिस्ट्री। आज केमिकल काइनेटिक्स के दूसरे लेक्चर में हम लोग सीखने जा रहे हैं डेरिवेशन ऑफ इंटीग्रेटेड रेट इक्वेशन ऑफ फर्स्ट ऑर्डर रिएक्शंस। सो आओ केमिस्ट्री सीखें। लेट्स एंजॉय केमिस्ट्री। Dear students, we are going to learn about the derivation of integrated rate equation of first order reaction. Let us say if there is a reaction R is equal to P. If it is a first order reaction, that means rate of this reaction will depend on concentration of reactant to the power 1. The rate, which is generally written as minus d concentration of R upon dt, will be equal to a constant that is called as rate constant K into concentration of reactant power 1. That's why it is called as first order reaction. Now our aim is to get integrated rate equation from this differential rate law. So to get the integrated rate equation, we can integrate this, but before integration we will slightly modify this equation by bringing this concentration term from right hand side to left hand side and dt term from left hand side to right hand side. As a result, we will get slightly modified equation, this equation. Now what we can do, we can integrate both the sides of this equation. Since minus k is a constant, so we will not integrate it, but we will integrate this dt. So on integrating both the sides of this equation, we will get integrated form. If you remember, dr upon r on integration becomes log of r and dt on integration becomes t. So integration results into this equation. Ln of concentration term is equal to minus kt plus integration constant I. Our next task is to find out value of integration constant I. If you remember from zero order reaction, value of I can be found out by considering this reaction at a special time, that is at the beginning of reaction when T was equal to 0, the concentration of reactant was equal to initial concentration, that is at T is equal to 0, R is equal to R naught. By substituting these values in this equation, we will get ln of R naught is equal to minus K into 0 plus I. So value of I comes as ln concentration of R at time 0, that is R naught. Now what we do, we substitute this value of I in this equation. So while substituting, we get equation like this: ln R naught minus kt plus ln of R naught. Now what we do, we take kt to left hand side, from minus it becomes plus, and we bring ln of R to right hand side. So it becomes ln of R naught, which is already present on right hand side, minus ln of R. Now when two log terms are being subtracted, that means the variables are getting divided. So kt becomes ln of R naught upon R. Now this is the log at natural base. If you want to convert it into base 10, which is easier for calculation, so we have to multiply it with 2.303. So instead of ln, now we will write log, concentration of reactant at time 0 upon concentration of reactant at time t. So we get equation kt is equal to 2.303 log R naught upon R. If you want to write it in terms of K, so T will come from LHS to right hand side and we get a better equation. K is equal to 2.303 upon T log of concentration of reactant at time 0 upon concentration of reactant at time T. This equation is the integrated rate equation of first order reaction. All the calculations which I did by hand have been printed here. So it is good to have a look at those calculations. Once we substitute value of I in the equation, we get a new equation which can be rearranged to this form. And here we can further rearrange it by keeping K on one side and taking minus T on other side. And on rearrangement, we get an equation like this. K is equal to 1 upon T ln concentration of R at time 0 upon concentration of R or reactant at time T. The last thing we have to do here is converting log from natural base to at base 10. For this, we have to multiply the log term with 2.303. Once we multiply, we get K is equal to 2.303 upon T into log of concentration of reactant at time 0, that is initial concentration of reactant upon concentration of reactant at time T. This is the integrated rate equation for first order reaction. Now coming to some of the examples of first order reaction. The first example is hydrogenation of ethene. Ethene is an unsaturated gas. When it is made to react with hydrogen, it converts into ethane, and it is a first order reaction because rate of this reaction depends on concentration of ethene power 1, or rate of reaction is directly proportional to concentration of ethene. Coming to second example, all natural and artificial radioactive decay of unstable nuclei also take place by first order kinetics. Apart from these two examples, decomposition of N2O5 to form NO2 and oxygen, and decomposition of nitrous oxide N2O are also some more examples of first order reactions. So this is all about derivation of integrated rate equation of first order reaction. Thank you.